Be quite an intimate part of the day, but let's start. So I'm about to talk about config schema. Let me introduce myself a bit first. My name is Joris. I am an event organizer. I'm part of the board of Drupal Belgium, and because of that, I got to interview Dries at Drupal Dev Days last year, so that was quite fun. I've been presenting on Drupal-related stuff for a bit over 10 years. I maintain the search API and facets modules together with other people. I don't do this on my own. And currently my special interest is config schema validation stuff in Drupal core. So that's what I've been spending a lot of my time on. So let's start building what config schema is a bit. So there are two parts of config. One we call simple config. A simple config is basically one thing. It's your site settings, it's your custom module settings, it's your search API settings. It's basic overarching things that can be deployed to a different site. As a really important rule, they should not depend on anything else. So they should be completely isolated in their configuration. And then there's a config entities, which is a view, is a config entity, a search API index, a web form. Like there are different kind of things that are config entities, but multiple of these things can exist. You can have more than one view on your site. Well, you can have only one view settings thing that is overarching for your site. They can have dependencies on other types of config as well as on content sometimes. And they can also depend on simple config, but not the other way around. So as a simplified thing, like both of them are deployable, both of them can have dynamic schemas, but for simple config there can be only one instance and they can have no dependencies on other config. Like one of the long-term goals of config schema validation is to make it possible to validate your config without the Drupal being present. And for a simple config, that's actually quite possible because you only have to validate that it fits with the defined schema. It gets a bit more complicated when you're looking at config entities because they can depend on another config and then you need to make sure that this also exists, so that becomes more difficult. But basically it's YAML. It's introduced in Drupal 8 and it is discovered when a config schema lives in the config schema directory. It's based on Qualify, and Qualify is a schema/metadata language for configuring YAML files. It's written in Ruby, and it's actually a complete implementation of what config schema ended up being in Drupal, but multiple years before it. It's not 100% the same, but it is what we used as our basis for going further. So there are multiple schema types. All config schema is about subtyping other types. And all types from a subtype and a parent type end up being a compiled type together. And all of these are defined in a schema file. So the root type or the fallback type that we have is undefined. So if you have a piece of config and it doesn't have a schema, then we fall back to undefined. And undefined just tells it basically nothing, but it is the only thing that we have to fall back on. So it is the same as there not being a schema, but we need to have something. And then we have a bunch of scalar data types. We have string, boolean, integer, all these kind of things. And they define a class as well as a label. And this class type makes a config schema linked to typed data, which is a system that you use every day when you're like going into a node, getting a field, getting data out of that field, like these kind of things when you do that in code, that's all through the type data API. This type data API is also what is the underpinning of how we are working with config in Drupal. from a code perspective. Then we have a bit more complicated data types, like I'm going to show a lot of code, but most of it, like I will always show what file it's coming from. You don't have to read all of it, but what I would want to show here is that we have, next to our basic scalar data types, we have 2 array-ish data types. You have a sequence and a mapping. The difference is, for a sequence, it doesn't matter, it's like the keys are the same as an array without keys, it's just like 0, 1, 2, 3, and it doesn't matter what the key of it is, the key doesn't have any special meaning. While for the other one, for a mapping, the key does have an importance in the schema. And I will come back to that a bit further. And by default, we are not doing any validation on what those keys can be, but it will become more important later. So every property, every type has several properties. These are them, but not all of them have to be defined on every level. Because it's an inheritance thing, they just keep typing on top of each other, they keep stacking on top of each other. So they have a type, which is in a usual case, it's a string or a mapping or something like this. It has a label, which is a user interface label. It doesn't have to match like a configuration form thing, but usually it makes it a lot easier if you do match it. It has a translatable key, and if you have it translatable true, that means that it is now allowed for this config to be translated, and it adds all the plumbing in the config translation part of the admin. It has a class, but that's only needed for the base types, and that's so we can tie it into type data, and then we can add the mapping or the sequence depending on if it's a mapping or a sequence. So this type data thing that I've been talking about, in this case, we have a get casted value, and this is the value of this thing. I'm not going to go deep into type data, but it is quite important to know that you're never interacting with raw config. You're always talking through type data and the type data layers to talk with your config. So let's look at a bit of a more complicated data type. This is a data type that's in core. It's a required label. Doesn't sound super complicated, but let me make it more complicated. So this one has a validation and it's not blank, which means that it can be null, but it cannot be an empty string, because a label that is an empty string doesn't add any value to anything, really. So this, if we're looking at this is actually, so it has the type label, which means that we're going to look at the label type. The label type is a type string. It is translatable, so that means that our required label is also translatable, and it has a regular expression constraint. In this case, there cannot be a tab or an enter in, or any other kind of control character in the label, because a label with a tab inside of it doesn't make sense, and labels are not allowed to span multiple lines or contain any of these control characters. So this is on top of this, and on top of that we have the string, which links it to the string data, the type data. So a required label extends a label, extends a string, and when we put this all together, we have a complete data type, which means that our required label is, instead of a type label, it's actually a type string, but like we inherited to get there. It has this class, it has the translatable property, it has both of these constraints. It has both a not blank constraint and the regular expression constraint. So that means that every time you're making a type or building up on a previous type, you're mashing all of these things together to create a complex shape of what a property in a schema is supposed to look like. So if we're looking at a simple config, let's say, for example, system maintenance, we have a type here, which is a config object, and a config object actually extends mapping and a bit of other things, but that's the main thing it does. It has a label, and then it has a message what to display when a site is in maintenance mode. And this is a simple, about as simple as a config can be. And this is actually also a type. So that means that another config can extend this config or use this as part of, because we are looking at, the message is also a type text. But if we were to create a different config, simple config, then it could have a property that has system.maintenance as its type. You see, this is all of it is the same because it's all just types. And a config entity is also just a type of a different one. In this case, it has an ID. It has more things, but I will get to that later. Am I going too fast? No? Good. I think I am because I'm already halfway through my slides. But we will see where we end up. So we've expanded a bit on this facets schema. So it has this ID that we saw earlier. Then it also has processor configs. Facets is a thing where you can define some processors on it, and they end up doing multiple things. In this case, our processor configs is a sequence, and this sequence is a mapping of processor IDs and settings per processor. So for example, we're going to create a facet, and we're going to say, oh, this is a Boolean, so we're going to add the Boolean facet processor to it, and we're going to add another facet processor to it, and this will all end up in this mapping. So we're using this special syntax here, parent.processor ID, and this parent.processor ID actually means look at our parent and look at the processor ID value of that parent and use that as a type. So this is going to dynamically compile to a new type. Let's see. Plugin configuration .facets processor .boolean item. So this is the same thing, but we have Boolean item as our processor ID. So it can use this, and this has another mapping inside of it. So we're now 4 mappings deep, and this has an on value and an off value. So the configuration for that is quite simple. But you can actually go a little bit further, and this is another one. This is a granularity item. You don't need to read this, but you can see like our Boolean only needs 2 properties, and this one actually needs a lot of properties. And because of dynamically defining our configuration schema, we can make sure that we only expose the properties for this specific processor if it needs it. And this way we can be quite specific in how our configuration looks, but we don't have to overload. If you don't need the granularity item, you don't overload your config schema with a lot of things that you have to make nullable because you don't need them in case you don't need this processor. And actually, like this kind of parent magic works in a couple of different cases. So you can use a subkey of a property. You can use this parent.name or parent.id, parent.type, whatever parent.something next to this. You can go up another level, or you can use the type of it, which is the type of the element. I will come back to an example of that as well. Actually, I think this is it. So this is the config schema for date formats. And you can see I highlighted a couple of things in red here. So our type of the pattern uses a Boolean called locked, which is next to it. And when it is when it's not enabled, then we are using type date format. So that means that the date has to be an actual date format. It needs to be another entity. And if it is locked, then we're just using string as the data type. So we're changing the data type of a specific type of a property in a type dynamically based on a sibling value. And then we have fallbacks. So if you were to define everything all the time, you would end up with a lot of config schemas, and a lot of them would have some repeats in them, and that's not super interesting to do. So what actually exists is a way to type something that's dynamic in a way. In this case, entity view displays. It doesn't matter if it's a node or a taxonomy, or if it's from the article bundle or the tag bundle or whatever. They all need to have a target entity type property on them and a bundle property on them as well. In this case, we're just like everything that we're ever going to create, every entity and every bundle and every view mode within that bundle always will have this as a schema, as a basis. And other things can build up on top of this. So, I didn't tell you at the start of this presentation, but I'm from Belgium. So I'm going to talk about beer. So if you want to create your own types, this is all that you need. You create in your custom module, you create a schema file, you add a type to it, and that's it. Now you have a type. And in this case, it's just a string, because we're extending the string type and we're not making it translatable. And then we're going to add other things up on top of it. We're going to make sure it's not null, and it's one of these options. So the color of our beer is white or yellow, red, brown, or black. Actually, if we're doing it like this, that's probably not great, because if we invent a new type of beer, then we're going to have to go into our schema and change it. But at least, like, I don't imagine any new beers ever appearing, so this is it. There are ways to do it differently, but let's say we're going to use it. So we have a beer config schema, which is a config object, and we're going to add a color type to it. So this is now using our custom thing. We're also going to add this fully validatable thing. And this fully validatable thing means, and I'm going to read a part of this because it's otherwise a bit tricky, I might get it wrong. So all values in my config schema are now required because I have this fully validatable thing on it. I can change this by adding a property onto a type to make it no longer required, but by default everything is required. Which means they have to have a value. It cannot be null, it cannot be missing. A particular property can be marked optional by specifying nullable true, and then in that case, it can have a null value, but it's still, the key still needs to be there. In my exported config, I still need to have this key. So all keys of the mapping must be present. So adding this fully validatable thing means all values in this configuration must be explicitly defined in the schema. There can be no additional keys and no missing keys. So once you say this is fully validatable, then we in Drupal can say, okay, I see an extra key here. I'm just going to error, tell the developer something is going on, this is not right. So that was the fully validatable thing. Now, I think this fully validatable is nice, but the options, as I told you before, actually maybe this is not great. So instead, I will add a beer color constraint onto it, and this constraint we will write ourselves. So it's actually relatively easy. We're using the same system as Symfony is using in their configuration, in their constraints system. So Symfony is using this for their form builder. In their form builder, you can also do validation. This constraint system, we've reused it exactly as is for config schema validation. So in this case, I'm going to add a constraint, and I'm going to say it extends the Symfony constraint, and the only thing I'm going to add to it is I'm going to add a message. And then next to that file, I'm going to add a validator file, so it has to have exactly the same file name, except it needs to add this validator part to it, which is not the way we do things in Drupal usually. Usually we would have some kind of property on top of it, or an annotation that links the two things together, or some kind of YAML file to link them together. But this is not how it works because we are using the Symfony thing. So you just need to have it in the same namespace, in the same directory with this validator part on top of it. And in this case, I'm just going to, I haven't implemented the isValid property here, but there you would do some kind of API call to see what beer colors exist, I guess. Whatever, you write your business logic there. But this is like adding your own custom constraints on top of this. Now, why would you want to do this? Like, it's a lot of work. Like, okay, you have everything strictly validated, but why? Well, actually, a new thing that ended up landing in Drupal 10.3 is config targets. And this means that in your form API, you're going to add this config target. And in this case, it's media.settings. And then I'm going to look at the standalone URL type in that schema file. And this will add all the validation that we've defined in the config schema automatically to this form. And it will also automatically do form submissions. So when I don't need to have any submit form handler in this form, Drupal will automatically say, oh, this config target, this standalone URL, I need to save it into this file, into this schema. And that will automatically be wired up together. Now you say sometimes it doesn't need to be exactly the same thing, and we have actually thought about this because you could also add a config target object to this config target property on your form, in your form API. And there you can do like callbacks to convert to a Boolean or convert to something else depending on what your form looks like. Like here you can just do weird things to make it work for you, for your use case. So that's a super easy thing to do to create advantage for you out of defining your schema. Because it's one line in a config schema. We've already, actually it looks like when we're adding config target form things into Drupal, most of those commits end up looking like -200 +2 in your div stat. Like it's actually really useful to do. We also have this config inspector thing in as a Drupal module. It exposes this config inspect thing. I'm not going to show everything it can do because it can do quite a lot of things. But one of the things it can show you in your installed Drupal site how many of those configs are correct or not correct according to the schema, how many properties of this schema, how many of the subtypes of this schema have config validation added to it, and does it pass this validation or not? And if we look at it, like I installed Drupal CMS this week, we have 629 configs defined in the Drupal CMS 2.0. And of them, 137, so more than 1/6, almost 15-20% of them are 100% validatable, which is great news. When we're looking at it, actually, we started doing this kind of validation stuff a couple of years ago, and it ended up being Wim Leers, Vena Proxima, and I, that we did a lot of these things together. we've started at about, Drupal was 0% fully validatable. Like it just didn't happen. And actually of things that were validatable, we were at like 16% of all the config schemas in Drupal core, which is not a lot. Currently we're at 43% relative progress, which is the thing that we look at mostly, which is not great, but you can clearly see a trend there that we're moving towards more validation, more strictness in this config schema thing. So I haven't gone over everything that config schema can do because it's quite a lot. But there is this cheat sheet that Gabor Hoitzi wrote. If you want to know more about this config cheat sheet. Oh Jesus, this is super difficult to say. This is, if you Google this, you will end up on Gabor's blog, and you can find this PDF there, and explains everything even more. So I think I went a bit fast, but are there any questions? Is everything more or less clear? Yeah.
Thanks for the presentations. Do we need to have we do use config inspector on our local on DDev, but do we need to push it on the CI, the CD CI, to give make for custom projects of the communities to push the validations?
Yeah.
Is it worth it?
So I'm going to repeat it for the recording. Is it worth also doing this config inspecting thing in CI/CD? That's basically your question, right? And that's super interesting because I haven't thought about doing this myself yet, so I'm not sure. I think like this chart I showed, this is an R script. So R is data validation stuff. So what we're data science language. So what we're doing is we're doing an install every day of Drupal core, doing a config inspect, writing that to a JSON file, and then doing the checkout of the next day, doing a config install, doing config inspect. So that's how we are creating this, and we're already only at 50% for Drupal core. So if you are going to validate your project, you're never going to end up getting very far today. So today, I don't think it's worth it for you, for your project. I think it's worth it for your contributed modules to look at your config schema and see that everything is fully validatable and correct. I think that's actually a good thing to do. But I don't think, putting it in CI might be wasting CI minutes, in my opinion, because you're not changing config schema configuration definitions very often, I think. So I wouldn't put it in CI. You had a question?
Yeah, I have an edge case. Yeah. I'm contributing a module, Index Now, which has sub-modules. So the main module has schema.yaml, fine. But the sub-modules are extending the schema of the main module. How would I put these configs from the sub-modules? Should I put it in the main module? Or?
So you're wondering about sub-modules for a contributed project?
Yeah.
That's a good summary,
right?
right?
Extending the settings from the main module.
Extending the settings from a main module, yeah. Okay, there are several things I have to say about this. First of all, which is just maybe just a more general remark, but submodules is actually a feature of Drupal that I'm not sure is going to stick around for much longer. Because it's actually, when you look at it, you cannot do a composer require of a submodule because it is not a thing on the package list. And so if we want to integrate more with these kind of tooling, then I don't think submodules is a thing that we should be supporting for much longer. But that's just a tangent, a side quest. So there is a thing called third-party settings, which is a thing on. Actually, I might be able to show this. Yes, so third-party settings, we're looking at an implementation of it, but this is an extension point specifically designed where one config can accept configs from different modules or different entities or different kind of other things that can end up being merged into the same thing. So third-party settings is a good place for like a standard extension point of config where it can accept different kind of other things into it. So your main module could have a third-party settings, your submodules could define their own things and push it into the third-party settings of the main module's config. That could be an option to do it. I think that might be the most default way of doing it. Otherwise, if they all are just using the type of the other one and extending it with some kind of thing or using a processor kind of architecture, I think the config should stay as close to the code as possible. So I wouldn't put it in the main module, I would keep it in the submodules. Okay. And otherwise, yeah, look into third-party settings as an option. It's built-in extension points. I cannot zoom. Maybe I can. So configuration entities have third-party settings, which is a sequence of the type parent.parent.type.thirdparty.key, which is all these kind of dynamic typing stuff all put together in one thing. But this is like, for example, contact form has this to provide an extension point. So that might be a good one to look at as well. Okay, I'm going to zoom back out of that. Yes?
Sorry, I missed that. But I think yes, and I will ask something like absolutely relevant. But we know like the application of config schemas was just translations. Okay. And I think now it is it is somehow related to canvas stuff. And it is like all this, which I didn't have any single look at canvas. I mean, doing some working. I just see that it's like strict about configurations, and or I'm totally wrong. But I'm just mixing up like totally different things.
So you are right that config.
Can you repeat the question?
We'll try to repeat the question in my answer.
It's impossible.
You are right that one of the bases of adding config schema was to assign a translatable key to some of the types so we can know, oh, this label is a translatable label, this is not a translatable label. These kind of things is one of the bases of creating this, except it was also created for ease of deployment workflows. Like you're exporting to config to deploy to another site, right? So it has multiple purposes, but you're right that this translatability was quite important, and you're also right that, like when we started with the config schema validation stuff, Wim and I we had 3 goals in mind. One was we want to validate a Drupal site's config without the Drupal being there, maybe even without PHP being around. That was one very weird goal that we had in mind. It's currently not possible, but this was a thing. Then we also wanted to look at maybe we can remove all form validation and submission from all config forms and use config for that. That is currently possible with the config target thing. And then the next part was we want to enable an admin UI that's built in not Drupal, not PHP, but that talks over an API and still validates all of the things. It validates the same way as form validation happens. And because of this, we also have this validation, because all of our constraints are now validatable outside of the forms and are now an option to be validated through an API endpoint. And Canvas is making use of this option to validate config strictly through an API endpoint, and that is the way that they are also using this. So you're right that Canvas has been a driver for some of the config validation strictness things that we've been doing the last 2 to 3 years. Does that answer your question at all, or does it create more questions?
Well, it kind of brings things together, but like technically, if you don't have schema for a model, whatever, like it won't break anything.
No, if you don't have a schema for your config, then it doesn't break anything because it falls back into the undefined type.
Yeah, but with Canvas, it still doesn't break anything, so it validates this config through API. But it's still possible to go with, say, invalid config.
Yes, you don't have to, like config schemas are kind of optional. You can get away without doing it, but like maybe it is my personality, but I like to have things like defined strictly and validated against, like for me that feels very safe that the thing has a shape it is supposed to be, and that we can validate that the thing that we have matches this shape. It feels very nice to me, but that's my personality maybe. Okay, I think that was it, so thank you.